Hello, this is Mrs. Schaefer. I wanted to go through the 5.05 elements and compounds video with you. The lesson material is going to be talking about the difference between elements and compounds. We will be noticing that when you combine elements to form these compounds through bonds, that their properties change. So we'll be looking at review sheet questions 12 through 15 on the review sheet. That will be the last of the review sheet questions for chapter 5. There is a discussion quiz that goes along with this to help us practice and make sure we're understanding this idea. So we've talked about elements and compounds before in our chapter 1. So you can refer back to this, and there's a screen here from our chapter 1, the difference between what an element and a molecule is. Then you also have this idea of compounds. So molecules mean that there's more than one atom attached. So these are molecules of chlorine, molecules of hydrogen. They're considered elements. Compounds mean that there are two different types of atoms being held together. So when they don't match, they're compounds. They still have chemical bonds between them. That's what that representation of them squashed together looks like, is showing that they are sharing electrons. So hydrogen and hydrogen are sharing electrons, but so is the nitrogen and oxide. And scientists like to come up with different names for different things. So we have different names to help us there. So a compound, two or more elements combine to form a compound. They have a unique chemical and physical property set when they're combined. So it's going to be different. Oxygen is going to behave differently by itself than it does when it is bonded to something else. And the composition is what we're going to call the chemical formula. So we have this idea again, just as a reminder, that a compound has two or more different atoms in a fixed ratio. A molecule is composed of two or more atoms. They're usually the same thing. So two oxygen, this is example of two oxygen bonded together, that's a molecule. Carbon dioxide is a compound. Okay, so we know that these elements can bond together, these atoms can bond together. It's a pure substance because it cannot be physically separated. So they combine with their other elements and the outer electron shell, or the valence electrons. And a chemical formula tells us what makes up a compound. That's its chemical composition. That's our review sheet question 12. So here's a couple examples of that. Two atoms of hydrogen, one atom of oxygen, and you get water. Two carbon monoxides plus one oxygen gives us two carbon dioxide. That goes to your review sheet. Question 13, what is this molecule right here called? Carbon dioxide. Di meaning two, so it means two oxygens, carbon and two oxygens. Now in chemistry, a more advanced chemistry class, you would be learning how to name these, but we're not going to do that. I will give you the names. You will be expected to know and recognize water and carbon dioxide and probably methane, some of the simple ideas. But we use our periodic table to determine what the symbol is. You'll notice that the first letter is always capitalized. And it will have 2 or 3 letters. Most of them are 2, but you'll see that some of these do have 3 letters to help name them. And that's how we come up with that chemical formulas. We're using the periodic table, and we'll find the name of the element and use that symbol. The first letter is always capitalized, the second is and third is always lowercase. So when you see the capital letter, it's saying a new element. So let's look at this in detail. So in this case, we have a capital N and a lowercase a. So Na is the element name. It's actually sodium. Na does stand for sodium. And that 2 down here says that there are 2 sodium atoms. Then we see another capital letter S. That is sulfur. And there is no number down here, no subscript. Always assume 1. We don't write out the ones. And then we have oxygen, and we see that there are 4 oxygens. That's capitalized, so that is an element. And if we went back to our periodic table, we could find each one of those: sulfur, sodium, and oxygen. So that's how we put that together. So this chemical compound contains 2 sodium atoms, 1 sulfur atom, and 4 oxygen atoms. So do the elements, if I put the element H and O in different containers, would they act the same as if I had a container of water? Because H and O, 2 H's and 1 O, back here in our example, form water. Oh, my mouse disappeared. All right, so we can see that we have those 2 hydrogen, the oxygen, we form water and energy. And if we look at their properties, the answer is no. When elements form a compound, the compound was going to have different properties from its elements. So we can look through and examine and see that hydrogen and oxygen both have different properties than water. These chemical compounds always come in a fixed ratio, meaning that if it's water, it will always have 2 hydrogen and 1 oxygen. If it is HO, that's something different. It's called hydrogen peroxide. So each composition has its own chemical formula, its own ratio of molecules, and the chemical and physical properties are unique. It might have some properties of each of them, but there's some uniqueness in there too. And you can see from this example, you can look at it and pause anytime you need. Here's another one. Table salt is Na plus Cl. Notice the N is capitalized, the A is lowercase. The C is capitalized and the L is lowercase. So you can go to your periodic table and you can find Na over here and Cl over there. So we have a metal with a gas, and that's how we get table salt. So what does the Na stand for? It stands for sodium. Cl stands for chlorine. And you'll see that some of them, their abbreviations are based on either their Latin name, because Latin was the language of scholars for many years. So many of these abbreviations have symbols that are different from their beginning of their name. All right. So here's another one. Ammonium is made up of 1 part nitrogen, that light green right there, and 3 part hydrogen, 1, 2, 3 on the outside. What is the correct chemical formula for ammonium? So how do we write it correctly? All right. Hopefully you saw that there's 1 nitrogen and 3 oxygen, so you add it that way. Now the difference between this here, this subscript, and this here, so this is saying there are 3 hydrogen atoms and 1 nitrogen atom. This way, when you put the number in front and it's large, what you're saying is you have 3 molecules of NH. So when you put the number in front, it tells you how many of those there are. Um, all right, so we need to look at pure substances and mixtures. Here's some pictures. You might want to pause this and look at this. Make sure you understand the difference between a pure substance and a mixture. Notice the bonds. Those where the 2 molecules touch, those are the bonds. So pause this, go through this carefully. It will help you as you recognize the difference between a mixture and a pure substance, a compound, and an element. So elements, two things of the same type bonded together can be an element, or they can be single. If it's a compound, they've got to have a bond. That means they have to be touching and they all have to be the same. So from here, see if you can practice determining which ones are which, elements or compounds. There is a discussion quiz that there will be a separate recording for that on there to help you so that you can go through and practice this information. You will find it in your course. Have a great day, and we will see you next time.